Welcome to the video for lesson 9.3a for Expo. Our objective is to solve quadratics by graphing. So we've been doing all this work on how to graph a parabola. Now we should probably talk about why we would want to do that. So let's cover a couple things that we've talked about so far with the graphs. Consider the function y equals, this one says 3x squared minus 8. So the first thing is, does it open up or down? Okay, we're looking at the A term and we're looking at the C term right now. So if the A term is positive, that's when we open up. Okay, and what we look at with A is if it's bigger than or less than 1. So if it's a number that's bigger than 1, like A is right now, that's when we have a narrower graph. Okay, it's wider if it's a fraction between 0 and 1. The negative 8, what effect does the negative 8 have on the graph? That's the C term. So what that's looking at is moving the graph down 8 units. If C was positive, it would move up 8 units. Okay, so just knowing what the A term does, knowing what the C term does would be great. Secondly, we have the word problem. So a basketball is thrown into the air with an upward velocity of 24 feet per second. Its height after t seconds is given by this function. So when they give you that function, just being able to understand that what we're looking for is usually the vertex in this situation. So they're going to give us this. Okay, we want to first answer, when will the ball reach its highest point? So to answer that question, we need to use the axis of symmetry formula, which is the opposite of b over 2a. So b for this one is 24. So the opposite of b is negative 24 over 2 times negative 16. So what we're really dividing is negative 24 over negative 32. And that should be a positive number every time. That gives you 0.75 seconds. Okay, what you do with that number is you plug it in. So that's how long the basketball takes to get to its highest point. The question of how high will it be at that point, we just plug that answer in. So it's like we're taking the height at 0.75 seconds. So that's negative 16 times 0.75 squared plus 24 times 0.75 plus 4. So if you do negative 16 times 0.75 squared, that part gives you negative 9. Plus, if you do 24 times 0.75, that gives you positive 18, and then plus 4. So what we have here is a total of 13. So this should also be a positive answer. We're talking about feet, so this is 13 feet. It takes 0.75 seconds to reach a maximum height of 13 feet. Okay, so that's what we've done so far with the word problems. We kind of add on to that too when we get to the quadratic formula a little bit later on. So we've done a lot of graphing. Okay, the question is why, or why would we want to? The reason we would graph a parabola is to figure out where the solutions are. So the rest of this chapter is going to talk about how to find solutions of quadratics. And we're going to have 4 ways that this chapter will cover. Okay, so basically everything up to this point has been pre-work of how we can solve. So our first method is going to be graphing. That's the one that we're going to look at today. And then we'll start to look at some more algebraic methods that are usually a little bit faster. So what we're talking about when we solve a quadratic is we're looking for what makes that quadratic equal 0. So when you're trying to find solutions, you're just looking for what end up being x-intercepts on the graph. So graph the related equation. Okay, the solutions are the x-intercepts of the graph. Okay, so if we want to solve a quadratic, we want to set it equal to 0 and see what x values make that equation equal 0. So in this graph, they've done all the work for us. They've graphed it. In this graph, there are 2 solutions. Okay, our parabola hits the x-axis right there, and it hits it right there at -2 and at +2. So what those are are the two numbers I could plug in to make that equation equal 0. Because again, I'm graphing this equation. So if I plug 2 into that equation, I get 4 minus 4, which is 0. That's a solution. If I plug in -2 into that graph, -2 squared is still positive 4. So 4 minus 4 is my other solution. So this particular parabola has two solutions. You could have two solutions. You could have one solution, or you could have no solutions. And I'll give you some examples of each of those. You'll learn about non-real solutions in Algebra 2. But in this course, solutions refer to just the real number solutions. Okay, so the key idea here, all right, is the solutions are the x-intercepts, which are the zeros of the equation. What do I plug in for x that makes the equation equal 0, that makes y equal 0? Okay, all right, let's move on to some examples. So in this graph, first thing we want to do is just graph it, see what the solutions are. Okay, remember you could end up with one answer, two answers, or zero answers for all quadratics. So what are the solutions? Use a graph of the related function. So x squared minus 9. Tomorrow we'll do this a different way that's a lot faster. So what we're looking for, if there's not a b term, is we just make a table and we plugged in 0, 1, and 2. All right, and once we knew our answers for 1 and 2, the 1 gives us the same answer as -1, and 2 gives us the same answer as -2. Okay, so if you plug in 0 to any equation, you're just going to get out what c is. So for this one, a is 1, and c is -9. Okay, so that's all that's happening right here. Okay, so if you plug in 0, you get out c. So 0, -9. Okay, this graph starts down 9 on the y-axis. All right, so there's our first dot. Okay, then we need to plug in 1, and then that'll give us the same answer as -1. So plugging in 1, oh, there we go. Plugging in 1, you get 1 squared minus 9. So that's 1 minus 9, so that's -8. That's also going to be our answer for -1. So I need a dot at 1, -8, and -1, -8. Okay, then plug in 2. So we got 2 squared minus 9. Okay, and that's going to be 4 minus 9, so that's -5. So I need a dot at 2, -5, and -2, -5. Okay, so there's my graph. Okay, something like that. So this is a graph that has two solutions. Okay, that's what we have here. If I go one more number here, if I plug in 3, okay, it looks like 3 is about where this graph is going to cross. If you plug in 3, okay, what you end up with is 3 squared minus 9, and that's 9 minus 9, so that's 0. So that is a solution right here. X equals 3. That's a solution. That's where the graph crosses the x-axis. And then it should be the same for -3. If you plug in -3, that also would give you a 0. -3 squared minus 9 is also 0. So this graph, we graphed it. It crossed the x-axis twice. And that's why we have our two solutions there. So our solutions are x equals -3 and x equals +3. Okay, they are both answers. Okay, it's okay to have two answers when you solve a quadratic. Okay, let's look at another one. Okay, this one a little bit different on how to graph because now it has a b term, right? So if you're looking at this one, okay, the first thing we need to do is find the vertex. So we should really have these two steps flipped, but that's okay. So we have x equals -b/2a to figure out the axis of symmetry. So for this one, okay, it's the opposite of b, so that would be -4 over 2 times a. If there's not a number there for a, then use 1. So 2 times 1, that's -4 over +2. Those divide to -2. So that's our axis of symmetry. Okay, so what that is again, oops, just hitting the board in two different places at the same time. So what that is our dotted line that cuts the parabola in half. What we need to do with that -2 is we need to plug that in to find the vertex. So the vertex is at -2 comma something. Okay, we just have to plug in and figure out what that would be. So we're going -2 squared plus 4 times -2. There I go again, messing it up. There we go. -2 squared plus 4 times -2 plus 4. Okay, what that would give us, okay, the -2 squared, that's 4. 4 times -2 is -8 plus 4. So if you look at 4 minus 8 plus 4, okay, that actually gives you 0. What that means is that's one of our solutions right away. So we're at -2, 0. Okay. From there, we should plot the y-intercept. That's always a good one to get. Okay, that's at 0 comma c. Okay, and c is 4 for this one. So 0, 1, 2, 3, 4. Okay, and that will help us because if there's a purple dot 2 to the right of that red line, I need another one 2 to the left of the red line. And then we can get one other point. So we could use 1. I'm going to use -1 this time because I don't have a dot right in here. So I could see what comes out if I plug in -1. So you know what? I'm going to change my mind. I think it'll still fit on the graph if I use +1. So I'm gonna go ahead and switch that. I'm going to plug in +1 and see what comes out. So that would be 1 squared plus 4 times 1 plus 4. Okay, that's 1 plus 4 plus 4, so that's 9. So if you plug in 1, you get out 9. So 1, 9. And then 1, 2, 3, 1, 2, 3. I would also have a 9 right there. All right, so here's my parabola this time. Okay, so the question is, does this one hit the x-axis? And if it does, how many times? And it does hit the x-axis once. It hits right here at this green dot. So what that means is there is a solution. There's a way that I can get y to be 0, okay, when x equals -2, okay, then y equals 0. So this one only has one solution. And that happens. That's something that's normal. Doesn't mean that we did anything wrong. Okay, so it's possible to have two answers. It's also possible to just have the one answer. Okay, let me show you another example. So this one, okay, what it would look like if you don't have any of those solutions. So if we can look at x squared minus 2x plus 3. So a is 1, b is -2, c is +3. So we need to do x equals the opposite of b over 2a. The opposite of b is actually +2. Okay, b is -2. So we're looking at the opposite of -2, which is +2, over 2 times 2. 2 times 1, my fault. Which is just 2 over 2. So x equals 1. Okay, so this time, here's our axis of symmetry. Okay, so we need to plug in 1 and see what comes out. That's going to be our vertex. If you plug in 1, that's 1 squared minus 2 times 1 plus 3. Okay, and that's 1 minus 2 plus 3. Which is essentially 4 minus 2, so you get out +2 for that. So there's our vertex. Okay, so our first dot is right here. Okay, from here, you're going to open up because A is positive. So this one, something a little bit different happens, something that we haven't seen yet. So the y-intercept is 0, whatever c is. So that would be 3 this time. So we need a dot at 0, 3. That's one step away from the red line, so I need another blue dot one more step away. Okay, so then getting one other point, so I have a dot at 0, 1, and 2 for x, so I'm going to plug in 3, just the next smallest number that I can, and see what comes out. So for this one, that would be 3 squared minus 2 times 3 plus 3, and that's 9 minus 6 plus 3, which is 6. So if you plug in 3, you get out 6. So I need a dot at 3. 1, 2, 3, 4, 5, 6. That's 2 steps away from the red line. So I need another green dot 2 steps to the left. And here's my parabola. Okay, so this one is another unique case. This one doesn't hit. Here's the x-axis. That purple parabola is never going to touch it. So if it doesn't cross the line, that's when there's no solutions. Okay, what we call it is no real solutions. We throw that word in there. Your Algebra 2 teacher will tell you more about why we throw that word in there. So no real solutions. If it doesn't hit the x-axis, sometimes the parabola starts above and opens up. Sometimes it starts below and opens down. That would have no solutions either, right? But what we're looking at for this one is that it never crosses the x-axis, so it doesn't have any solutions. Our domain and range are something we can still answer. Okay, it's still all real numbers for our domain. Okay, there's no x values that we can't plug in. The range is talking about y. When it opens up, that means we have a minimum. So we have some smallest number, and all the other y's are going to be bigger than that number. And what we used was the lowest the graph ever got. And what that ended up being was the y value of the vertex. So y is always greater than or equal to 2. All right, so that's an example of each one. Okay, so to solve quadratics by graphing it, you graph and then you look for the x-intercepts. Okay, there could be 0, 1, or 2 answers. So that's why we graph. It's not the fastest method, especially if we're doing it by hand. So the rest of this chapter is just other methods that make it so that we don't have to graph. All right, so thanks for watching. Go ahead and try the assignment, and we will see you soon.